let's face the types of reaction undergone by organic compounds. We have numerous reactions, but we will take the most common reactions that organic compounds undergo. One is the so-called substitution reaction. Number two is the addition reaction. Then number three is the polymerization reaction. Under that polymerization, you can see condensation polymerization and addition polymerization. So under substitution, you can see different types of substitution reaction. So these three reactions, some might see the elimination reaction, of course, but the three common ones I'll be handling are the addition reaction, the substitution reaction, and then the polymerization reaction. Okay? First, substitution reaction. What is a substitution reaction? Substitution reaction is a type of reaction that is undergone or that is observed in saturated compounds. Say saturated. Saturated compounds. So this is a type of reaction that is observed among saturated compounds that involves the replacement or displacement of an atom by another atom, or replacement of an atom or a group of atoms by another group of atoms in a saturated compound. So any reaction that occurs mostly in a saturated compound is what we call substitution reaction. Let's use football team. Normally a team in football, standard football field, requires 11 players. If a team has contained 11 players, that team is saturated, is okay. And that leads us to the term saturated compounds. What are saturated compounds? Compounds that contain the maximum number of hydrogen atoms it can normally hold. Saturated organic compounds are organic compounds that the carbon atoms are bonded to the maximum number of hydrogen atoms it can normally hold. They are usually identified by the presence of carbon-to-carbon single bond. Any organic compound that have carbon-to-carbon single bond throughout the molecule is a saturated compound. If there is a presence of double or triple bond, it becomes now unsaturated. Therefore, it is the saturated compounds that undergo substitution reaction. Why? Because they have attained their limit. They have attained their climax. They have contained the maximum number of hydrogen atoms they can normally bond to. Earlier, I told you that carbon is tetravalent in excited state. When the whole orbitals in the last shell of the carbon are used for formation of bond with other elements, we say that such carbon is saturated, of course. So such compound will undergo nothing but substitution reaction, whereby one of the hydrogen atoms are replaced by either a halogen, an oxygen, a metal, to form other new compounds. And that is what we call substitution reaction. It's a type of reaction that is unique for only saturated compounds. But the exception to this is benzene. Benzene is unsaturated. Fine. Why? Because it has 3 double carbon-to-carbon bond in its molecule. So the ring of benzene has 3 carbon-to-carbon double bonds, which alternates with a single bond and also are delocalized. Benzene is unsaturated and undergoes substitution reaction. This is unusual. Why? Because of the delocalization of the pi orbitals, meaning they are not fixed, just like we see in the straight chain or open chain compounds. Okay? So, substitution reaction settled. Then the next reaction is addition reaction. Addition reaction is a type of reaction that involves the addition of an attacking reagent across the double or triple bonds of an unsaturated compound to yield a saturated compound, or at least one with a higher degree of saturation. So addition reaction is unique to compounds that are not yet satisfied. They are the so-called unsaturated compounds. Unsaturated compounds, by definition, are what? These are compounds in which the carbon atoms are not yet bonded to the maximum number of hydrogen atoms they can normally hold, and they are identified by the presence of either double or triple bond. In other words, alkenes, olefins, and alkynes, generally called the acetylene, are all unsaturated, and therefore they undergo addition reaction because of the presence of what we call pi orbital, pi bonds. So pi bonds are broken by addition reaction. Any molecule that have what we call pi bonds or pi electrons undergoes addition reaction. But any molecule that lacks pi electrons but have only the sigma orbitals or the sigma bonds, which are very strong bonds, they don't undergo addition reaction, which means alkanes lacks pi orbitals or pi bonds, and that is why they don't undergo addition, because they are saturated. So the bond broken by addition reaction is the pi bond, which is a weak bond, or the pi orbitals, of course. So addition reaction is observed among any organic compound that possesses a double or a triple bond, and we refer to them as unsaturated. Now, the next reaction I made mention of is polymerization. Polymerization is actually the joining or the linking of smaller molecules known as monomers to form a larger molecule with a giant weight, what we call macromolecule, and that macromolecule is referred to as polymer. So the joining or linking of monomers to form a giant molecule known as polymer is called polymerization. So it's a feature of some organic compounds actually, like ethene can link and give us a complex compound known as polyethene. Because of this, organic compounds deviate from the normal Dalton's law of Dalton's atomic theory, which says that when atoms combine, they do so in simple ratio to one another, meaning when balancing equation you use simple numbers such as 2, 5, but when you come to polymerization, thousands of molecules join, 5,000 of molecules join to form a giant molecule. So polymerization deviates from normal Dalton's atomic theory, which says that when atoms combine, they do so in simple ratio. No, in polymerization, they don't do so in simple ratio, rather, they do so in complex ratio. So polymerization is divided into two. We have condensation polymerization and then addition polymerization. So this condensation polymerization involves the same definition of polymerization, that's the joining or the linking of the linking of monomers with the elimination of a small molecule such as HCl, water, and so ammonia. So when small molecules are eliminated from the joining of the monomers, you call it condensation polymerization. But in addition polymerization is just the linking or the joining together of monomers without the elimination of small molecules, such that what you garbaged in is what you garbaged out. Remember that you are on with Sir Majesty Easy World Science Channel. I cannot do without you. If you are enjoying this class, what do? Spread the light. Please, I beg of you, I beg you, and I plead with you, please, to subscribe and also share this video with your colleagues and your friends. Spread the light. We also need your sponsorship. In case you are looking for a way to equip your laboratory, Sir Majesty Easy World Science Channel is the ideal company that will help you equip your laboratory. Most things I say, I test their quality. Some I produce them myself. Some scientific tables, such as periodic table, I have designed a unique periodic table which contain more information than any other table you can find, so you can buy from the Easy World of Science. If you are really enjoying this, please subscribe and share. Thank you for watching. Bye for now.